There are a few things to keep top of mind when implementing the MidSchoolMath curriculum. It's really important to note that it's rooted in the brain science behind growth mindset. So the first thing we want to do is really get students immersed in meaningful mathematics, where we're looking at contextual situations that really happen in real life, and you have students using the math to interpret those situations. For that reason, when we start a lesson, we want to immerse students in a context where math is meaningful. Yeah. All right, eyes up, ears up, and let's take a look at the video.
Now, what do you see?
I see dots. Many dots.
Look closer. I believe those dots may be telling us something very important.
That was entertaining. In a second, we're going to do something called a waterfall, where everybody who has a thought is going to raise their hand all at the same time, okay? So when I say go, if you have any hypothesis to what the data are showing, I want you to raise your hand when I say go. All right, think about it. It's your hypothesis. It can't be wrong. All right? Go. Okay, I love that. You get it? Waterfall. Everybody had it at the same time? Okay. All right, great. Okay, so yes, Meow Wolf, because the last time I was in Santa Fe, I did not get to go. Tell me.
I think the deaths might be the data might be showing the location of the deaths.
It could be showing the location of the deaths, right? So what are we going to need in order to answer that question? Who can build off of what we just said? Yes, what do we need in order to answer what the data are showing? The graphs. We need some graphs. Anybody agree? If you agree, do this. Okay, all right. Fortunately for you, some of you have not flipped your pages. Some of you have, and that's totally fine. So what I want us to do, find the paper that's on the table in front of you. You're going to flip that over. Before we start talking, eyes on me really quickly. I want us to take a solid 60 seconds. I'm going to put it on my watch, okay? A solid 60 seconds, and we're going to try to notice and wonder about the data we see. Notice means, I noticed this thing. Wonder means, I wonder why this is happening. Notice and wonder. So you ask some questions, and you're going to be able to give some statements, right? Okay, so first, we're not going to talk to partners. We're just going to take a look at it side by side, okay? After the timer goes off, you're going to have 2 minutes to exchange with your partner, okay? Everybody has a white paper in front of them with data on it, correct? If you do not, raise your hand. Everybody's good to go? 1 minute of silence for you to find that information by yourself. Notice and wonder. Go. So, I heard a lot of really great stuff. I was walking around and I designated some groups. So we're going to start with group 1. Group 1, if you wouldn't mind sharing out. Yes, stand and deliver. Everybody follow group 1. We're going to stand and deliver. That'll be great. Group 1 is going to tell us about the Dan Street well.
The Dean Street well, the bacteria is growing a lot faster because it's like people are dying closer to their homes, which means the bacteria might be growing faster in the Dean Street well. It might have something to do with like the temperature of the water in the well is what I'm thinking.
You agree?
Yeah.
I love that. I love that. Let's give 2 snaps for that group. 1, 2, 3. Awesome. Thank you for sharing. Group 1B, you're going to share as well. And you're going to tell us about the Dane Street well from Artifact 1, right?
Yes.
Okay.
Something I noticed from the Dan Street well is that most of the deaths are coming from 1 to 2 kilometers away.
1 to 2 kilometers. Okay. So what I'm understanding is, if we're all taking a look at the front, you're saying most of the deaths are occurring somewhere between 1 kilometer and 2 kilometers away from the well. Thank you for that. Any other information you want to add? Okay, thank you. And lastly, group 3. There we go. Group 3. You guys are telling us about the Broad Street well.
Yes.
Okay.
That the virus thing is
growing more near the number of. Wait, what? I'm sorry.
You started off strong. You said you think that the disease or the virus is growing where?
More away from where the home.
Distant from home
The
water
home.
well.
Okay, so you have more viruses closer to the well or farther away from the well?
Farther away.
Farther away.
Okay, farther away from the well. Okay, thank you for sharing. Everybody on the count, was there more information? You sure? Okay, on the count of 3, everybody give them 2 snaps. 1, 2, 3. Okay, thank you. So if you notice, like normal, I did not answer your questions. I did not say, yes, you're right. I didn't say, no, you're wrong. Because what I want you to do is continue to think about what information we're gathering. So right now, all we're doing is gathering information. We're going to wonder about that information. We're going to question that information. We're going to affirm that information. So we've heard from 4 groups some of the hypotheses that we have about what the data is showing. Let's take a look at all 3 graphs one more time. And we're going to look to find what's our overall hypothesis. I want every group to come up with one statement that you're going to tell me about answering what the data is showing. So your statement should be, the data is showing us that, and then I want your idea of what's happening, okay? It's also very important to create space for students to lean on each other. As a teacher, I like to step back and really take the role of facilitator so that the answers come from the students and from the story. Who can repeat what we're about to do? For just 1 minute, you're going to take some time with your group, and then we're going to share out. Who can repeat the directions for me? Yes.
We're going to take a minute to make a hypothesis on what we're going to answer the question, what is the data showing?
Boom. Everybody ready? Anybody need anything else? 60 seconds. Go ahead and come up with a hypothesis with your group. All right. If you can hear my voice, clap once. If you can hear my voice, clap twice. If you can hear my voice, say, woo. Okay, awesome. So I love what I'm seeing. I love the excitement. I love the questions that are happening. I was walking by Cora and Josiah's group, and I heard Cora say something that I thought was pretty interesting. So Cora, could you share out what you think the big question is, or the big answer to what the data are showing?
There are more deaths closer to the wells than anything else.
So be thinking about that. There are more deaths closer to the well than people who live further away. Some of our graphs are showing some interesting information. We also don't have a map that might show us where, even though I'm close to or farther away from one well, maybe I'm closer to another one, right? So we're going to take a moment, we're going to watch the rest of the video, and we're going to see how our hypotheses play out, okay? Any questions so far? Okay.
The other graphs seem to have nonlinear associations. I see no discernible pattern.
Except for one.
The Broad Street Well.
How crazy was that, right? So now what, if we were to think about today, what is it that you know about your town or cities or establishments? I know some people play those video games where you build these cities, right? What does your city or your town have to have in order for something like cholera not to happen? Any ideas? Yes.
Good water source and good food.
Water sources yep.
A clean water system.
A clean water system. So there's a bunch of places that now, I mean, cities have these water filtration systems, places where sewage is designated to go, and places where water is designated to come from so that it's not contaminated. I want us to keep in mind how we're integrating content too, right? Because the first thing that my friend said back here is that, well, I can see that there might be a heavy outbreak in this area, or the virus might be concentrated in this area. And while we're thinking about math and data, I also want us to continue to think about how data is not random numbers on a graph, right? It's really used for us to interpret things or for us to show someone else something, right? And so it can help us simplify and explain things. And I really like the way you guys are thinking. So if you can give yourselves, all of you, 2 snaps when I say 3. 1, 2, 3. Okay, we're going to pause here. We're going to move to the next section of the lesson, okay? Teacher messaging is also critical. We emphasize that making mistakes is part of the learning process. It offers us all opportunities to grow. So now we're going to launch our simulation trainer, okay? When I say go, not yet, okay? When I say go, we're going to go ahead and click the red launch button, and I want you to walk through the simulation trainer, giving it your all, but I want to keep in mind two things, okay? Here are our reminders for today. The first is we are all owners of our learning, okay? Just like any other day, Mrs. Johnson is not giving you answers. There's no yes and no here from me, okay? What I am going to encourage you to do is to continue to lean on each other. So while you're walking through the simulation trainer by yourself, you do have a learning partner next to you. Lean into that person for questions or lean in for support if you see that you can support, okay? Number two, I also want us to remember when we do hit those stumbling blocks and we go, oh, I made a mistake, or oh, I didn't get it. Just remember that every time that happens, we are building one more brain synapse, okay? Everybody good? Everybody ready? Let me hear you say, we ready.
We ready.
We ready.
We ready.
All right, on the count of three, you can go ahead and push your launch button. 1, 2, 3, launch.
I still kind of don't understand it.
I kind of understand it.
So tell us more. What are you thinking?
I'm thinking, so I plotted the 1 right here,
Mhm.
where it says 1, and then I went across, I went up and did 6, it says right here.
So you started with the left column, right? And you found 1,
Yes.
because you guys are looking at different wells, which is fine. You started with the first column,
Yes.
found 1 on which axis?
What?
Which axis? Where did you find the 1?
Right here in the
Okay, on the x-axis. Great. Okay, and then you traced that up to
the y-axis.
the y-axis and found which value?
6.
The 6. Okay, and then you plotted your point there.
Yes.
Okay, so tell me what you're thinking now. Thank you for that example. How do you think we can do this first one? You have some
You have to find
different
0
numbers, right?
points and on this part.
Okay,
And then I have to find the 3 on that part.
okay. So this is 7/10, right? Okay, where is 7/10 you think on the graph?
Around here.
Okay, all right. So we just got some really helpful information, right? That this column is going to be us working on the x-axis, okay? So I like that. So let's think, here's which number?
1.
What's in the middle of 0 and 1? Right in the center, what would it be?
1.5.
0.5, very good. So 5/10 is going to be in the middle. Let's count how many tick marks are in here. Ready?
1, 2, 3, 4, 5, 6, 7.
So we have 10, is that right? Okay. So we're going to find number 5. 1, 2, 3, 4, 5, 6, 7. So 7/10 is going to be this line, right?
That one.
And then we're going to go up to 3 on the x-axis.
So like right there.
Boom. All right. Okay. Thank you. You think you got it? I'm going to come back, get these 3, I'll come back and check, okay? Awesome work. Thank you. We want to highlight that students taking responsibility for each other and for each other's learning is really what supports and builds a strong learning community. Okay, if I can have everyone's attention just for a second. Thank you so much. We're just going to take 1 second. Hold on. Pause your conversation for me for just 1 second. I just want to remind you that when you do get your green dot, just remember to pop up, because as we are owning our own learning, I'm going to need you to walk around and kind of support your peers, okay? Sound good? So when you get that green dot, jump up like you won the lottery, because that is what happened, okay? Your prize is getting to support me and supporting your students, all right? All right. Even during teacher instruction, we want to reduce anxiety. So we offer opportunity for students to just sit back and listen and then take their notes. Okay, 1, 2, 3. All eyes are on me, okay? I want some opportunity and some time to help you synthesize some of the information, okay? I don't want these pieces hanging out all disconnected, all right? So let's walk through the simulation one more time, what we saw, what we heard from it, and let's make some mathematical sense out of that. Okay, we good? All right, during this time, you do have your pencil and paper and your sheets in front of you. I don't want you to have to take notes right now. I want you to really focus in on me, my words, on the screen, on what's happening, and I want you to be able to just soak in, because sometimes it can be pretty distracting. Who finds this distracting sometimes, taking notes and trying to listen at the same time, right? And so what we're going to do, we're just going to pause on taking the notes. We're going to immerse ourselves in the information, and then we're going to step back and recall, okay? So all of our pencils should be in front of us, as in on the table. We shouldn't have anything in our hands, and we're just going to focus up here for a second, okay? All right, so let's go back to what was happening. In Europe at this time, there was a big cholera outbreak, right? In that time, Dr. Snow was creating some information, recording where people lived, trying to figure out where these deaths were happening and what was happening in those areas, okay? What we came up with, or what he devised rather, is these graphs associating where some water wells were, water sources, in connection to where people lived and where they were dying, all right? What we saw was that the Broad Street well gave us a pretty clear, maybe even patterned example of what might be happening associating water wells and distances from them as far as deaths were concerned, okay? So what we mentioned earlier, if you remember, we said, well, based on some of the well information, we don't actually know the Broad Street well, the James Street well, the Dean Street well, where they are, right? We got the information, but we couldn't see a map. So now we have a map, okay? You see where the homes are. Each red dot represents where the homes are. What we're going to do as these dots kind of transpose, we're looking at where they were when he set up a graph. So this graph is showing the connection between one variable and another variable. So to add some color to this, you have the distance from the Broad Street well and relating it to the number of deaths. In mathematics, we're going to call this relationship, we're going to call this a negative association, okay? A negative association really just means that as one of our variables is increasing, the other variable is decreasing. So later I'm going to ask you to start thinking about what might be some of those negative associations or relationships that you can think about happening in your own life as you see relationships, okay? So we call these associations associations of bivariate data. Bivariate data really is just going to mean bi, think about two. Vary, think about changing, right? So you have two variables, two pieces of data that you're relating to each other, right? These are just some examples of what kind of patterns you might have with bivariate data. One of them on the right might be more common. As we've been learning about how to graph things, we normally see a positive linear relationship between certain variables, whether it's miles per hour or something like that. We're watching how things increase as the other increases, okay? So this is a different look for us. Thinking about negative associations. Here might be something that's more common. As we drive a certain distance, so distance increases, what decreases? Our gas, right? So as we move more miles, our gas in our gas tank is decreasing. That is a real world example, or another one, of a negative association, okay? So remember, our negative association is as one variable is increasing, the other variable is doing something else. We're going to pause here. I want you to go ahead and pick up your pencils and write down any information, in fact, all of the information that you remember. Whatever you can recall at this time about the patterns, about the negative association, about bivariate data, go ahead and write that down. I'm going to take about 60 seconds to jot down and recall anything and everything that you can. Remember that mathematical drawings can also enhance not just someone else's understanding, but your memory, your recall, okay? So let's think about you adding some pictures, some mathematical drawings, graphs, whatever that is, that helps you to recall some of that data. And that might actually be a helpful place for some of us to start. I saw some of us are a little bit stuck. If you remember any of the mathematical drawings, Go ahead and start that. Put that on your note page, okay? We want to be careful to avoid the pitfalls that might hinder a growth mindset. For example, with print worksheets, there's a tendency to want to assign them individually and silently. We like to use protocols that continue the collaboration even with print materials. When I say go, here's what will happen. Our 1s are going to come here. Our 2s are going to come here. Our 3s are going to come here. Our 4s are going to be here. Our 5s are going to be up in this group, and our 6s will be over here. Okay? All right? So here we go. Actually, grab your pencils, grab your materials, and we're going to move to our stations, okay? This is just a reminder. You've got about 20, 25 minutes to work on all 3 problems. So you're probably going to have to split your time up a little bit, something like 7 or 8 minutes per problem. You are in groups so that you can, 1, do what? Who knows why you're in groups? Raise your hand. Yes, sir.
Help each other.
So that we can lean on each other, okay? We're not all going to have all the good ideas, but one of us and some of us will have some of the good ideas, okay? We're going to be able to recall that information. You do have your notes. You're going to work on your printable. All 3 problems, you need to do your best to get through them together. Closing out the lesson with a formative assessment is pivotal to our teaching practice. And for the students, the clicker quizzes allow for continuation of collaboration and the classroom discussions. All right, we're going to go to the next question. What is the purpose of a scatter plot? A, to display the relationship between 2 variables. B, to write a linear equation that relates 2 variables. C, to prove that one variable is causing another. Or D, all of the above. Remember, you and your partners have to agree before you can choose your answers. Hoo-hoo. I hear some arguing up there. Justify your answers. Convince each other. Okay, I'm hearing us getting a little quiet. Ooh, I'm going to open the vote. I hope we're ready.
Okay.
Go, you have 10 seconds to vote. Ooh. Oh boy, oh boy, oh boy, oh boy. Oh! Yes. The answer was A. To display the relationship between 2 variables. Ah. So we have to think about why so many of us picked D. And I'm not sure who picked E, but we didn't have that. But it's okay. Made a tiny mistake, no big deal. Or you were being funny, so let that be your last joke. Self-assessment is especially important to the growth mindset because it gives students a chance to pause and have a metacognitive approach to their learning. I want us to take a look at the self-assessment like we do at the end of every class. And I want you to find, using the rubric on the bottom, what is the true kind of reflection? Which words reflect where you are right now with today's lesson? You have 4 different columns. Says, I don't get it yet. I'm working on it. I'm almost there. And I got it. Wherever you are is where you're supposed to be. Finally, when it comes to complex tasks like student reflections, it's important to remind students that it's a process and that draft 1 is your first step.